This is page 70 in our notes in this paper. We're cutting up and taping into our notes or trimming it up to put in our notes. So this talks about area of polygons. So this goes with standard geometry 1 and talking about breaking up into smaller shapes. How would you find the area? So specifically I want to look at question 1 here. They're giving you the area of this here is 64 centimeters squared. And then they give you this over here is 10 centimeters. So how could you find the area of the entire shape? Well, there's a couple things you would need to know here. This is 64 centimeters squared. This is a square here. And so what do we know about a square? All sides are the same. So how would I get the area of a square? You need to know these two dimensions here. So some people can see it. They could see this would have to be 8 centimeters, and then this would have to be 8 centimeters. 8 times 8 is how you get 64. And so that's really all you need for the square. You also know that this would be 8 centimeters down here, and this would be 8 centimeters here if you wanted to label all sides. You could use the formula for area of a trapezoid, knowing that this entire shape is a trapezoid. Now that you know some of these other dimensions, looking at that square in particular. So what you could do is the trapezoid formula we said is base 1 plus base 2 times the height, and then divide that by 2. So what would I fill in here for my blanks for my base 1 and base 2 and then my height before I divide by 2? The bases are the ones that we call are parallel to each other. And so if I had to show with my pens which ones are parallel, they're going this direction. It's not like they're going up and down or anything. They're going this direction. So one base is the top 8 and the other base is the bottom. Well, what is the entire bottom here? You have 8 and 10. So together that would be 18. So you could say 8 and 18 are the bases that I'm adding. My height is the one going up that makes the right angle. The height is listed on the side. It's also listed here. That is 8, and then you're ready to use your calculator. 8 plus 18 is 26. 26, you have to take it times 8, and you have to divide by 2. And on your calculator, you would get 104 centimeters squared because it's area. Some people like to divide 26 by 2 and get 13, and then 13 times 8. Some people take 26 times 8 and then divide by 2. However, it works to get 104 centimeters squared. Another way you could find the area of this trapezoid is instead of making it one giant shape, you could find the area of the square and then add the area of the triangle to it. First off, the area of the square they'd already given you was 64 centimeters squared. And so if you want to break that down, that's actually 8 times 8 for its sides. And then you could add that to the area of the triangle, which the triangle, in order to find its area, you take base times height and divide by 2. So looking at what we know, do we know our base or our height here in our triangle to divide by 2? Sure. We knew the base was 10, and then the height we ended up finding was 8 when we broke down the area of the square into its dimensions. So base and height would be 8 and 10. Here, 8 times 10 is 80. 80 divided by 2 is 40 centimeters squared. So move this over so you can see that 40 centimeters squared. So if we know the area of the square is 64 centimeters squared, they had given us that to start, and we just found the area of the triangle. What happens when you add the square and the triangle together? You add those together, your 64 plus your 40, that would be the area of the entire trapezoid. 64 centimeters squared plus 40 centimeters squared equals 104 centimeters squared. So either way, you could break it down into two shapes and add those together and find the area of each one to get 104, or you could get the area of the entire thing using your trapezoid formula. This next part is just getting you to look at shapes a little differently here. These are 1, 2, 3, 4, 5, 6 sided shapes are called hexagons. I remember it because hex has an X in it, and the number 6 has an X in it. So that's how I remember that. What are two ways to break these shapes up to find the area? So they don't necessarily want you to find the area. They just want you to talk about how could you divide them up. So one way would be to divide it on this line right here. You would break this up into two shapes. What two shapes would you have? You would have two trapezoids. So could you find the area of this entire thing if you broke it up into two trapezoids? Sure. Find the area of each trapezoid and add them together. Another way people see it is to break it up by dividing it down. And so when they divide it down, you actually get a rectangle in the middle and two triangles. So you could get the area of the two triangles, and you could have the area of the one rectangle. And oh, not an S there, because there's two triangles and only one rectangle, and you could add those together, and then that would give you the total area. So just different ways to think about how you could break these shapes up and to find the area of them. Another thing that you're going to see isn't necessarily how, but how could you describe two ways to find the area of these particular figures? Okay, so this figure here is a trapezoid. So one way for figure A, you could figure the area by using the trapezoid formula. And so that formula is base 1 plus base 2 times the height divided by 2. And I'm not giving you the numbers to plug in, it's just how could you find the area? You could use that formula. The second way, you could break this down into, and you could divide it into two triangles and a rectangle, and you could find the sum of all of their areas. You could add each area together. So you would divide the shape into two triangles and one rectangle, and you could find the sum, because sum means to add, the sum of their areas. Add the areas of the triangles together with the area of the rectangle. This shape over here, shape B, I want you to describe two ways to find the area of it. One way would be the formula. Well, what shape is this? You need to know what shape it is, the formula. That is actually a parallelogram. So you could use the formula for parallelogram, which is base times height. Or you could break it down into different shapes. I see two triangles and a rectangle again. Again, you could find the sum of the areas for the two triangles and the one rectangle if you were to add those together. So part of this is just looking at how to break polygons down into shapes that are familiar. So your homework for this particular assignment that we're working on is a worksheet, page 119 and 120. You will do all on the coordinate planes, and they will be asking you to do some shapes and things like that.